Okay, I'm going to explain work problems now. I received several requests to explain the work problem I listed. So let's get more explanation in solving work problems. Let's see how we derive the basic work problem. Let's say you paint a room in your home in 4 hours. So now let's determine how much of the work you get done per hour. So let's divide this job up into equal parts. Since the entire job takes 4 hours, equal parts per hour would be, in the first hour, you would get 1/4 of the work done. In the second hour, you would get 1/4 of the work done. In the third hour, you would get 1/4 of the work done. That's 3/4 of the work. And in the fourth hour, you get 4/4 of the work done, or another 1/4. And so the total job completed would be one job completed, or one task, okay? Assuming that you work at the same speed for the entire job, this task per hour is called a work rate, or task rate. So therefore, work or task equal rate times time. And if we let variables equal our words, we would have, for work, we'd have W equals R times T, for rate times time. And if we would divide both sides of this equation by time, we would get rate equals work per unit time, okay? Where W equals work or task to be done, R equals rate, and time to do, T equals time to do the work, okay? So the total task would equal 1/4 task per hour plus 1/4 task per hour plus 1/4 task per hour plus 1/4 task per hour is equal to 1. And as you can see here, we have 1/4 task per hour. And that's something you learn in algebra. From first grade through 7th grade, you learn arithmetic. And from 7th grade through 12th grade in college, you learn mathematics. And what happens is you take the numbers in arithmetic, 1/4. 1/4 you only use for counting, okay? But in mathematics, when you graduate from arithmetic to mathematics, mathematics takes the arithmetic and you can use it to make decisions in your life, okay? You take the arithmetic you use for counting, then you take that arithmetic and you use it to make decisions. So therefore, the 1/4 means nothing but for counting. But when you put units on that 1/4, that gives it meaning, okay? So this 1/4 task per hour gives this 1/4 a meaning. It's tasks per hour, okay? So that's the difference between arithmetic and mathematics. And you learn this in algebra, okay? So rate can either be task per hour, task per month, or task per year. It's according to the problem, okay? And it doesn't have to be task per hour. So let's solve a problem and draw a table to see what we're doing. And here's an example problem. Let's say Ellen can paint a fence in 4 hours. Jane can paint the same fence in 5 hours. How long will it take to paint the fence if they both work together? Okay. So let's let X equal the number of hours required by Ellen and Jane working together to get the job done, the total job, okay? So let's draw a table. And in this table we see workers, rate, time working together, and work or task. Ellen, according to our problem here, can paint the entire fence in 4 hours. So Ellen's rate is 1/4 task per hour, okay? Jane can paint the entire fence in 5 hours. So per hour, Jane can paint 1/5 of the fence. So she gets 1/5 of the task done per hour. Okay. And X represents the time they're working together. Okay. So X times 1/4 is X over 4. X times 1/5 is X over 5. Okay. So we can now write our equation out here, work. And our equation is X over 4 plus X over 5 is equal to 1. One task. Okay. Now, if we multiply both sides of this equation by 5 times 4, or 4 times 5, the 4's cancel here and the 5's cancel here, and 5 times 4 is 20. Okay? The reason we multiply by x is because of this. In our table, we have 1/4 task per hour times x time working together, and that's in hours. Hours cancel. Hours divided by hours cancel. And that gives us tasks. Okay? And that's the reason for attaching units to these numbers. When you attach units to your numbers, that lets you know what you're doing and where you're heading. It lets you know what the numbers mean. Okay? So let's continue. So, okay, we got Ellen and the same table. Okay? So our equation is x over 4 plus x over 5 equals 1. We multiply through by 5 times 4. That leaves us with 5x plus 4x equals 20. And we add our x's up, 9x equals 20, and we divide both sides by 9, we get 29ths. Or Ellen, well, they work together for 2.22 hours. 0.222, as you see the line above, is a repeating decimal, okay? How do we change that repeating decimal? So that's 2.222 hours, okay? So working together to complete the job in 2 hours, 13 minutes, and 20 seconds. How did I do that? I took the 0.22 hours and I multiplied it by 60 minutes is 1 hour. So I put that as a fraction, okay? Well, hours cancel and it leaves me with minutes. So that's 13.333 minutes, okay? That's 1/3. Okay, I take the 1/3 and I multiply, because it's in minutes, and I multiply it by 60 seconds per minute. Minutes cancel, and then multiply by 60, that leaves me 20 seconds. And that's how I did that. So that's 2 hours, 13 minutes, and 20 seconds. Okay, so let's do another. Okay, Mary can do a certain job in 8 days. Jake can do the same job in 7 days. If Mary and Jake work together to complete the same job, how many days will it take for them to complete it? As before, we have our table, work per hour rate equals work per time, time working together, and our working task. So Mary can complete the job according to the question, 1/8 of the task per hour. Okay, and Jake can per hour can complete 1/7 of the task per hour. Then we multiply by the x times they work together, and we get our equation. X over 8 plus x over 7 equals 1. Okay, and then to clear out the fractions and get our x's on one side and our constants on the other, we multiply through by 7 times 8, or 8 times 7. The 8's cancel here and the 7 cancels here. 7 times 8 is 56. And so we get 7x plus 8x equals 56. 15x equals 56. And 56 divided by 15 is 3.7333 days. Okay, working together. Okay, so let's do another. And also, you would take that 3.733 days and calculate it the same way I did before. This is a little tricky. Okay, and there's a special method you can use to solve this, and I'll show you sometimes later how to do that. Okay, but right now it's a little in depth, and I'll show you later. Okay, let's try another. Tom is your chief transmission mechanic. It takes Tom 5 hours to remove a transmission, rebuild it, and then replace the transmission in the car without help. You decide you need this car ready in less than 5 hours, so you assign Joe, the engine mechanic, who can do the same transmission job in 7 hours, to help Tom. After Joe has helped Tom for 2 hours, the company president comes in with an engine problem. So you pull Joe to take care of the company president's problem. Okay, the question is, how long will it take Tom to finish the transmission job? All right. So let's draw a table. And from our problem, we have workers, Tom and Joe. We have a rate is equal to Tom complete the entire job in 1/5 of an hour. He can complete the job in 5 hours. So per hour, he gets 1/5 of the task done per hour. And Joe can do the entire job in 7 hours, so he can complete per hour 1/7 of the task per hour. Partial time they work together, okay, is 2 hours, okay. So let's see what they complete the task in 2 hours. So we multiply 2 times 1/5 and 2 times 1/7, and that leaves hours cancel as before, okay? Since they work 2 hours together, let's see now how much work they accomplished. Okay, so Tom work plus Joe work equals 1/5 job per hour times 2 hours. As you can see, hours cancel. Joe is 1/7 of the job per hour, and he worked 2 hours. As you see, hours cancel, and we're left with what? 2/5 of the job plus 2/7 of the job. That's the purpose of putting units there. Okay, so when we factor out job, we get 2/5 plus 2/7 job equals 24/35 of the job is completed and done in 2 hours. Well, if 24/35 of the job done, we subtract that from 1, the whole job. 1 minus 24/35 equals 11/35 of the job remains. Okay? So now let's let Tom working alone equal the number of hours required by Tom alone to get the job done after Joe has left. Well, Tom, as we know, gets 1/5 of the task done per hour times Tom working alone, which is in hours. Hours cancel, so that means he's got to do 11/35 of the job. That's so 1/5 times Tom working alone equals 11/35 of the job. That's the remainder of the job. Okay, we multiply both sides by 5, and 5 over 5 cancels. 5 goes into 35 7 times. So Tom works alone for 11/7 of an hour. Well, we divide 11 by 7, and we get the total time is 2 hours that they work together, plus the Tom alone hours equals 2 hours plus 11/7 of an hour. The total time is 3.57 hours. Okay? So, if Joe would have remained for the entire job and never left, the total time they would have worked together would have been 2 hours and 55 minutes. How did I get that? Well, let's check that. Let's let X equal the number of hours required by Tom and Joe working together to get the job done, as in our table. Okay? So, X over 5 plus X over 7 equals 1. Okay? We don't have the 2 hours there because Joe didn't leave. He stayed for the whole job. Okay? So we multiply our equation by 5 times 7 on both sides, and we get the 5's cancel and the 7 cancels, and we get 7x plus 5x equals 35. 5 times 7 is 35. Add up the x's, that's 12x equals 35. 12 over 12 divided by 12, 35 over 12, divide both sides by 12, x equals 35 twelfths. So if Joe would have remained for the entire job and never left, the total time they would have worked together is 35 twelfths, or x equals 2.9166 hours. But Joe worked 2 hours, and Tom had to complete the job alone. So the time is 2 hours plus Tom alone equals 2 hours plus 11/7 hour equals 3.57 hours. So by Joe helping Tom, his help decreased Tom's task time by 5 hours. Tom working alone would have done the job in 5 hours. But since Joe helped him, okay, you subtract 3.57 hours, and you get 1.429 hours, which comes out to be 1 hour, 25 minutes, and 43 seconds. Okay, let me introduce a more difficult problem to teach you how to work through a word problem. Okay, a supermarket hires 10 experienced men to stock their shelves Friday nights for the Saturday morning customers. These 10 men can stock the shelves in 8 hours. The manager has a bright idea. He says, to finish early, let's hire 15 inexperienced high school boys to stock the shelves. They did the same job last month in 12 hours. This way we can save money. The assistant manager states, we start stocking shelves at 6 p.m. and the men finish at 2 a.m. in the morning. If we use inexperienced high school boys, they won't finish until 6 a.m. the next morning. The manager says, then let's use a combination of 8 men and 12 boys. This way we finish early. So the question is, how long would it take 8 men and 12 boys working together to stock the shelves? Okay, let's make a table. Okay, now keep your eye on this table. We have workers, the initial number of workers, the time to stock the shelves, reduced number of workers, and their rate, and the time working together, and work or task time, which I have nothing there yet. Okay, so the initial number of workers is 10, and the initial number of boys is 15. Men is initial 10, and boys is 15. Okay. So we have to, this is a little different problem. So let's let X equal number of hours required by the men and boys working together to get the job done. Okay. Now, if we just include the men and the boys the way they are, 10 and 15, we solve the problem as we did before. But now we have reduced number of workers. Okay. So let's see how we would do that. Without the reduced number of workers, the question would be this. If men can stock the shelves in 8 hours and boys can stock the shelves in 12 hours, how long would it take if they work together? Then we would write X for the men working together with the boys. That's 1/8 of X plus 1/12 of X for the boys, because these are the hours. And if men can do the job in 8 hours, per hour they can do 1/8 of the job. If boys can do the job in 12 hours, then they can do 1/12 of the job, as we've done before. We're not considering whether we're reducing the number of men and boys. We're looking at the problem as if there's no reduction. Okay? So this problem is equal to 10 over 10 men, because 10 over 10 is 1. That's the same problem. And 15 over 15 boys. 15 over 15 is 1. So that's essentially the original problem. Okay? So the question is, how long will it take 8 men and 12 boys working together to stock the shelves? Okay, so if 15 boys can do the job in 12 hours, then the ratio of reduced boys is 12 over 15. And if 10 men can do the job in 8 hours, then the ratio of reduced men is 8 over 10. So therefore, we have the ratio of men times the rate of the men times the time working together, plus the ratio of boys times the rate of boys times the time working together, and equal to one task or one job. So we have 10 over 10 men times X men over 8 hours plus 15 over 15 boys times X boys over 12 hours equal 1. As you can see, 10 over 10 is 1 and 15 over 15 is 1. So essentially we are solving our original problem. But since we want to reduce this ratio from 10 over 10 to a different number, we can do that. So the question now is, how long will it take 8 men and 12 boys working together to stock the shelves? Well, that's 8 over 10 plus 12 over 15. Okay? And now we can solve this problem. This is a reduced problem. Okay? So how long would it take 8 men and 12 boys working together to stock the shelves? Well, as we saw in the previous problem, 8 As we saw in the previous problem, 8 cancels 8 and 12 cancels 12. That leaves us with 1/10 times xt plus 1/15 times xt, where I have xt equals total. And rather than men and boys, I put men and boys there so you can follow through, okay, where we're going. So we multiply both sides of the equation by 15 times 10, okay? 15 times 10 times both sides of the equation. And 10's cancel here, 15's cancel here. 10 times 15 is 150. Add up the x's. 15 and 10 is 25. Divide both sides of the equation by 25. That gets 150 divided by 25 equals 6 hours. Xt equals 6 hours. So they start at 6 p.m. and finish at 12 a.m. Okay. You got to remember that the last operation you encounter in any problem is arithmetic. Okay? No, regardless of how difficult the problem is. The last operation you encounter in any problem is arithmetic. So you need arithmetic to do mathematics. Okay? So study your mathematics. It's easy if you work the problems. In mathematics, you have to work many problems. That's just the nature of the game. Until next time.